All right, so today we're going to continue our journey into the exciting world of systems of equations. Two equations or more that the x and y value has to be exactly the same. Okay, so I can solve a system of equations by substitution. So I have two equations, 2x plus 8y is equal to 20, and y is equal to 2. Now, this one tells me exactly what y is equal to. So I can already start to write my solution because I know that there is a specific value that y is equal to. It's equal to 2. So for the y value, I put that in. So now, what I want to do is recognize the fact that if y is equal to 2 here, it's also equal to 2 here. And when I have a variable directly next to a constant, that constant is being multiplied by that variable. Well, now I know what the value of the variable is. So I'm going to replace the variable, not the constant. I replace the variable with what it's equal to. Okay, so now I just have to multiply 8 times 2, which is 16. And then just an equation just like any other equation that we have solved for 2 years now. We want to subtract 16 from both sides. Again, remember you're always trying to isolate the variable term first. And this zeroes out, and 20 minus 16 is 4. So I have 2x is equal to 4. And then I want to divide by 2 because I want one of the variables. And the only way to get a 1 in front of the x is to divide 2 by itself. But whatever I do to one side of the equation, I must do to the other. So I get x is also equal to 2. Okay? There is no resubstitution. I don't have to put anything back in because I already know what y is. Normally, in these types of problems, we find out what one of the variables is, and then we plug it back into one of the equations. Okay, but I don't have to do that in this case. And you also don't have to do that with problem number 2. And problem number 2, I would like you to try on your own. The only thing I will caution you is that it says x is equal to 5, not y. So that's going in place of the x value. Okay, so you want to set it up like this, and then solve for y. Okay? So you already know x, you just have to solve for y. And every solution should be written in this form where you have an x and y inside of the set of parentheses. Problem number 3. Very similar, except instead of an exact value for y, it tells us that y is equal to whatever x is times 2. So I'm going to take that and plug it into this equation. So I end up with 5x minus 2 times 2x equals 3. All right, multiply negative 2 times positive 2, I get negative 4x. That's equal to 3, and combining like terms, 5x take away 4 of those x's leaves me with 1x, or just x. And so x is equal to 3. All right, so my solution, I have x is 3 and y is still a mystery. So we've got to take that and plug it back into one of the two equations. It's much easier to plug it into the second one, although you're welcome to plug it into the first one. All we're doing then is taking 2 and multiplying it by the x value, and 2 times 3 is 6, so y is equal to 6. There is my solution for number 3. Number 4 is very similar. Again, caution you that this is the x value. That's going to go in for x. So you should end up with 2y plus 3y equals negative 15. Do your combining like terms and then solve for y. Once you find y, you have to plug that back into one of the two equations to solve for x. So you finish 4 on your own. And again, you can pause the video to do that so you can kind of keep working on the same types of problems as what I'm working on as I go through the video. Number 5 is a little bit more complicated, but not really. We still have y by itself in the second equation, and it says that y is equal to x plus 9. Again, I replace the y in the first equation, but I've got to multiply that entire thing, x plus 9, times 7. So it's not just x times 7, it's also 9 times 7. So the 4x I did not do anything with. 7 is being distributed. 7 times 1x is 7x. 7 times 9 is 63. Then I combine my like terms. I get 11x plus 63 is equal to 19. Now you get rid of the constant on the left-hand side of the equation. We want to isolate the variable term. So I get rid of the constant, which means I have to get rid of that same amount on the opposite side. This zeroes out. And 19 minus 63 is the same as 63 minus 19, except it has a negative sign in front of the answer. Why? Because the 63 was the larger of the two numbers. And when I take 63 minus 19, I get 44, and so it happens to be a negative 44. Then I divide both sides by 11. I get x equals negative 4. I still don't know what y is. So in my solution, I can write the negative 4 in for x, but I don't know what y is yet. Take that, bring it back up, and plug it into one of the two equations. Again, it makes no difference which equation you plug it into, but personally, I just picked the easier one. So the second equation rather says that we have y equals x plus 9. Well, x is negative 4, and we add 9 to that. That's the same thing as 9 minus 4, which is 5. So my y value is 5. Okay? Any confusion with these, look back at them. See what I did in each step so that you can duplicate that with the next equation. The next equation again says y is equal to 6x plus 11. That goes in place of y. So you will have 2 times the quantity, 6x plus 11 minus 4x equals 14. Distribute, then combine like terms, then solve to find out what x is equal to. Once you find out what x is equal to, plug it back in. Again, I would suggest the first equation in this case because it's easier, and find out what y is equal to. Okay. Now this leads me to the next page. There are 4 problems on this page. And every one of these problems is really roughly the same process. They're giving us y is equal to, or x is equal to. So this goes in place of the y. So I have 2x minus 8 times negative 7 minus x equals 6. That leaves me with 2x plus 56 plus 8x. Distribute the negative 8 to both of those. And just remember the negative times negative. Now I combine my like terms. There's a 2x, there's 8 more of those x's. Altogether I have 10 x's. Plus 56 equals 6. Now to get rid of the 56, I have to subtract it from both sides. That zeroes out. And remember, when you have unlike signs, you're subtracting. So we want to take the smaller number away from the larger, so that's really 56 minus 6, which is negative 50. Keep the sign of the larger number. Now we divide by 10, and I get x equals negative 5. I know x, but I don't know y. should say the value of y. So I take -5 and I plug it back into one of the two equations. Again, looks like the easiest one to plug it into is the second one. Now what you have to be really careful with is this double negative in front of the 5. That double negative makes that 5 a positive. So that's really -7 plus 5. Again, subtract smaller from larger. 7 minus 5 is 2. Keep the sign of the larger. So my answer is -2. Okay. Same idea with 8, 9, and 10. So I'm going to let you do those on your own. And then remember, there is another page. This says hardcore problem. Now I'm going to give you an example off to the side, and let's see how you do with this hardcore problem. If I said that one of my equations was 16x plus, let me go back and skip that plus. I'm going to put equals, because then it'll look like the one we have. Let's say 24 plus 8y. Okay, if one of my equations looks like that, I want to get that variable x by itself. I'm going to make one more adjustment so we don't end up with a fraction here. I'm going to make this a 16 as well. Okay, now, and I got to adjust something else I wasn't thinking. Let's go with 32. Okay, now I want to find something that will go into each and every one of those numbers evenly. Well, just so happens 16 goes into all of them evenly. And by doing that, 16 divided by 16 is 1. I get the x by itself. But when you divide, you have to divide by that number all the way through. So every term gets divided by that. 32 divided by 16 is 2. And of course, 16 divided by 16 is 1. Okay, so now I know what x is equal to, and now I can plug that into the other equation. So you're going to do the same thing with this first equation. Find a number that will make a 1 in front of the x when you divide by it. Divide every term, and then what you get gets substituted back in. So it's really only adding one more step. You have to divide by something to get a 1 in front of the variable. Good luck and go to it. Make sure you finish this by Wednesday.